So I wanted to talk first about the supported versions of RISAConnection and Tekla Structures, and then we'll talk about how the link actually functions within the two programs. So this link was released just last month, and it is a link between Tekla Structures and RISAConnection. So it will allow you to design your connections within your Tekla Structures model using RISAConnection. Now, this link is free to all customers who have both RISAConnection and Tekla Structures. And in order to install the link successfully, you will need to have RISAConnection version 3, and you can have any of the three versions of Tekla Structures listed on the screen, version 18, version 18.1, and version 19. And as this link progresses, you'll see that we'll continue to support new connection types, new versions of Tekla Structures, new versions of RISAConnection. So this is just kind of a snapshot of where we are today. Now, RISAConnection has a number of different connection types within the program, and the link has a number of connections as well. So right now on your screen is the number of supported connections by the RISA Tekla link. So you'll see we're supporting all of the standard shear and moment connections, clip angle, end plate, shear tab, and moment plate connections. Now, keep in mind that RISAConnection has a lot of other connection types that aren't listed here, and as we progress with the RISA Tekla link, you'll continue to see additional connection types added to the link. So when we switch on over from Tekla Structures to RISAConnection, you're going to see a lot of the additional connection types that you don't see in the link yet. But we plan to release every few months over the next year the RISA Tekla link, and we'll be adding new connections to each of those versions. So how does this connection link work, this RISA Tekla link work, and how would you implement it in your workflow? Well, right now the link goes from Tekla Structures to RISAConnection and then back. As Debbie mentioned, it is a bidirectional link, which means you can go back and forth as many times as you want. It is really important to start your model in Tekla Structures because this is how we define all of the different connections, what members they're associated with, what loads they go with. So you are going to start your model always in Tekla Structures. And then you're going to send that model on over to RISAConnection. And actually, you're just sending the connection information. So those connection design forces, bolt sizes, all of the parameters of that connection is going to go over into RISAConnection. And then RISAConnection is going to design that per the AISD code. You could choose ASD or LRFD, whatever you choose, whatever you'd prefer. And you might have to do some tweaking. So it's going to tell you whether it passes or fails the code check. It's going to tell you what fails. So maybe you're failing in bolt shear. So you're going to have to decide, do you want to increase the number of bolts, increase the number of rows, increase the bolt diameter. So make any changes that you need to your connection to get it to pass the code check. And then you can send those changes back to your Tekla Structures model. So that's going to update the model for you. So for those of you that are familiar with Tekla Structures, when you install this link, you're going to see an additional toolbar. And this is the toolbar here on the right of your screen. There are 3 options on this toolbar, and we're going to discuss what they are and how to use them. But that's going to be the only difference you're going to see in your Tekla Structures model. So again, you're going to build your connections in your Tekla Structures model, design the connections using RISAConnection, and then send all of that updated design information back. So I would like to get started and actually show you the link between these two. So I'm going to open up Tekla Structures here, and I have a model built here. Now, within your Tekla Structures model, you're going to assign your connections. So for this model, I've assigned quite a few different connection types. And if I zoom in on here, let me just zoom around so you can actually see the connections. I can see over here I have a 4-bolt shear tab connection. In the middle over here, I have a 3-bolt shear tab connection. Over here on the right-hand side, I have some end plate connections. So you can see I have a 3-bolt end plate connection. Over on the first floor, I can actually see my clip angle connections. So here I have a clip angle connection, 3 bolts on the girder side and welded on the beam side. So when you're in your your Tekla Structures model, you want to be able to assign your connections. So you can do that just using your standard macros. So if I go back on over to my PowerPoint presentation, if you remember, I talked about the supported connections here. And within Tekla Structures, you're using macros. So here are the different labels for the macros, or the numbers that we support. So for clip angles, we support macro 116, 120, 141. So these are the macros that we're going to be using within our Tekla Structures model to create our different connections. So I just want to be able to, reference those. So let's say I wanted to go over here to my middle bay here and add in some additional connections. So I'm going to go ahead and go into my Tekla Structures component catalog, and I can add anything I want. So you'll notice right now I have an end plate connection, but let's go over there and say I wanted something different. Let's say I wanted that standard clip angle connection, the 141. If I double click on this connection, it gives me all the different parameters of Tekla Structures for this clip angle connection. So I can make as many different changes to this as I want. I can change the notch. I can change the number of bolts. Is it bolted versus welded? Bolted, bolted, welded, welded. How do you want to treat this connection? Because Tekla Structures is a detailing program, it gives you a lot of options for modifying this connection. Now, if you're a standard Tekla Structures user, then you're probably used to this connection type, and you know that you can go in and kind of customize this. So you can tell Tekla, hey, every time I use a W12 member, I want it to be a 3-bolt connection, and if I use W16, I want it to be a 4-bolt connection. However, whatever your rules are, but you can go ahead and go in here and create those. So you're not creating them from scratch every time. Now, the key thing for sending this to RISAConnection is on this Design tab here. So in order for RISAConnection to know that you want to design this connection, you need to go in here to the Design, and you need to add in the forces that you want this member or this connection designed for. So right now I'm going to add a 40 kip shear force and maybe a 5 kip tensile force or axial force on this connection, on this clip angle connection. I'm not going to add any moment because it's just a clip angle connection. It's a shear connection, not moment. But if you were doing, let's say, like an end plate flange connection or something like that, a moment connection, then you can add in your moment. But it's really important that you add in these forces here as well. So I can go ahead and go in and apply this to my model. So I'm going to choose my girder, and then I'll go ahead and choose my beam there. So I can see that this is a bolted, welded clip angle connection. Now I could do the same thing with a different connection type. So if I want to go in here and let's say we want to go back to that that end plate connection, I can go ahead and go into my end plate connection. Again, you have so many different options here. You can add stiffeners, you can have notches, the different kind of bolts. But again, the key thing for sending it to RISAConnection is that you get this design type correct. So I'm going to go in here, I'm going to add a 40 kip force for shear and click apply. And then I'm going to click on my beam and click on my girder and then my beam. So I can see here that it's very easy to add in connection types. And if you ever want to know, hey, I see that's a clip angle connection in Tekla Structures, that's 141, but how is RISAConnection going to look at that? You can always just click on the connection there, and it's going to bring up a dialog box that shows you what that connection type is. So you can see here that it says this is the RISAConnection. The selected connection is a clip angle 141, and this is the ID within Tekla Structures. Now RISAConnection sees that as a girder beam clip angle connection. It's welded on the beam side and bolted on the column or girder side. So it's a very easy way to be able to look and see how are basically they translating it, or how are they mapping it from one program to the other. It's really just a viewer. You don't have to look at that if you never want to, but it is kind of a nice viewer. Now, there are there's a lot of different workflows that I've seen in the steel detailing industry, and depending upon what side you are on that, it may change. So if you are, let's say, you have a model and you do have a steel detailer and then you have a separate connection design engineer, at this point, once you have finished your detailing model and you've got all your connections and your forces and everything that you want in here, then you can go ahead and just say, I want to design the connections. And when you click this button, basically what it's doing is it's mapping all of these different connections. It's detecting all of the ones that you assigned a force to. And it's sending those on over to RISAConnection. Now, if you are, actually doing the connection design yourself, that's great. It opens up RISAConnection, and you're ready to go. If you are not doing the connection in-house, then you can simply close this. You don't have to keep it open. And what you're going to do is it creates a RISA connection file. So if I go into my, my model folder here, I'm just going to show you within the Tekla Structures model, I have this NASCC file is what I'm calling this. There is a file called NASCC-TLN. It's an RCN file. Now, if you are, having somebody else design your connections, you're sending it to your engineer, you just need to send them that file. They can open that up in RISAConnection by itself. They can make any changes, do the design, modify it, whatever, send it back to you. You'll replace that file that you have in that folder that I just showed you, and then bring those results back in. So that is one method. I always get that question is, well, what if they're not in the same office? So that's fine. You can just send the file back and forth and update the model that way. It doesn't require that you have Tekla Structures, on your machine to be messing with the connection design. Now, what I'm going to show you today is a different workflow, which is having Tekla Structures and RISAConnection on the same exact machine and making your modifications and sending them back and forth. So, you'll notice before I sent it to RISAConnection, you remember it opened up my, my RISAConnection model here. So you can see that it brought over all of those different connections. So it groups them by connection type. So I can see I have a 3-bolt end connection. I have a 3-bolt shear tab versus, 4-bolt to a column. So it's going to automatically group them based on the connection type. So, it makes it very easy to make modifications to a group of connections at the same time. Because most of the time when you're doing connection design, right, you're doing very similar connection design for all of the beam to girders that are W12 or whatever their, their parameters are. So once you get this model into your RISAConnection, the first thing that you want to do in your RISAConnection file is to run it. Does it pass? Does it fail? So there are a couple different options for running design within RISAConnection. Over here in the Project Explorer on the right, we have the name of the file, so NASCC. This is the file that contains all of the different connections that I have. So we call this the project. That's the whole project. And then we have these individual groups, right? So I have a column to beam flange plate moment connection. So that is a group, and there are 2 connections within that group. Now, the reason we do this is it makes it, we want to give you the ability to either make changes to the individual connections or make changes to the group. So when we run the analysis over here, you'll notice there are 3 different options. You can solve an individual connection, you can solve a group of connections, or you can solve the entire project. So when you first come in from Tekla Structures to RISAConnection, you want to solve the entire project because you want to know, does anything pass or fail? And then going forward, as we're going to look at this, we're going to make changes. I don't need to run the whole project again. I can just run an individual connection or maybe a group of connections, but it makes it a little bit easier. Now, you can see I ran that project, which has, quite a few different connections in it, and it ran it in less than, 5 seconds. It's a very, very quick run, which is nice when you have a larger model because you won't spend any time running the analysis and design. It just runs it very, very quickly. So on the right-hand side here in our project browser, it's very easy to see which of our connections passed or failed. So in the group heading, you'll see whether it says pass or fail. Now, if any of the individual connections within that group fail, then the group fails, meaning that it's kind of an indicator to say, hey, if I had a really long list in my my group over here, and you can see some of my other ones are very long, like my girder to beam shear tab connection, it's pretty long. There's quite a few connections within this. If any one of them failed, then it will tell you that this group fails, meaning that one of the connections in this group has failed. So I have quite a few connections that fail, and I have quite a few that pass. Most of the time for the ones that pass, you want to verify that they pass, but you're not really concerned with, what are the details of that, unless you're highly under stress, which I can see here. I have a unity check of 40%. That probably means I'm a little, I've got 4 bolts here. I probably don't need 4 bolts, so I could decrease that. But for the purposes of our demonstration today, we're actually going to look at some of the failing connections and try to get those to pass. Now, the first thing I notice when I look at this column to beam shear tab connection is it says it's failing, but my unity check is only at 80%. Well, that's a good indicator to me that there's something wrong with, my geometry or maybe one of my bolt sizes or weld sizes. There's something going on here. So what we want to do is investigate this a little further. So I'm going to take a closer look at this connection here, this first shear tab connection, and I'm going to take a look at the reports. So if I look at my reports here, it actually tells me what passes or fails. So I can see for this first connection in my column to beam shear tab group, I have a column weld that's failing. And let's see about my second one. So if I look at my second one here, I still have a column weld that's failing. So I can expand that and take a closer look, and it says the weld size is not allowed. So let's go ahead and change that weld size to a weld size that is allowed. So if I go over into my 2D view, and you'll notice here we have 3 different options on the left-hand side. We have a 3D view that you can go ahead and take a look at. You can, move it around, take a look at your connection. And we also have a 2D view, which is kind of like a detailed view of the connection with all of the different dimensions, the bolts, the welds, and everything. Now, the thing I really like about RISAConnection is down here on the right-hand side is where all the connection properties are. But I don't know off the top of my head exactly where my column weld is. I could scroll through and look here and see, okay, yeah, I see a column force, a story shore, okay, I see. But what's easier is that either within the 3D view or the 2D view, you can just click on that component. It'll take you directly to that portion. So I want to look at the bolts. I can click on the bolts. It takes me right there. If I want to look at the plate, I can click on the plate. It takes me right there. Again, the same thing in the 2D view. So if I want to look at the bolts, I can click right there, or the plate, or the beam. Whatever it is, you just click on it. It takes you right to that point in the connection properties, which just makes it really easy. Because one of the questions I get a lot is, well, I'm a Tekla Structures user. I don't really know RISAConnection. Is it a really hard program to learn? No, not at all. It's very intuitive. It shouldn't take you much time at all because it's literally just clicking on the picture and it corresponds and takes you right to that area of the spreadsheet. So for us, we want to change the weld for this one. So I'm going to click on the weld. Now you'll notice I did something in this model, a little bit odd, but I purposely tried to make it to fail. So you'll notice when it takes me to the weld here, I have a weld size of 2.9997, right? Not quite 3/16. And I did that on purpose because I want to get it to fail. I want to show you how you can make that change. Now, I can make this change just to this one here. So I'm going to say this is a 3/16" weld. And you'll see all of a sudden when I make a change to the connection, up here in my project browser, it says NA, which means you've made a change, but you haven't asked me to redesign the connection. So I'm going to redesign just that connection, and it gets it to pass. So I now know that that is the change that needs to be made. But since I don't really want to do that for each individual connection, I can actually go in and make that change to the group. So I'm going to click on the heading here, and I'm going to go down to my column weld, and I'm just going to change that to be 3/16. And then I'm going to rerun my group. Again, you'll notice that I'll go back and forth between designing an individual connection, a group of connections, or the entire project. And I really like the flexibility that that gives you, again, because it's quicker to do it, one group at a time than rather than redoing the entire project. So I can see, great, I got that to pass, so that's really great. So as I scroll down here, I notice that most of my connections passed, but down here at the bottom, my girder beam end plate connection and my girder beam shear tab connection are both failing. So I want to take a closer look at some of these girder to beam shear tab connections. So I'm going to look at this first one. I'm going to go down to my reports, and I can see that I have a number of things that are failing. Geometry restrictions, girder weld limitations, plate block shear, plate flexural yield. I have bolt bearing on the beam. I have bolt shear at the beam. So there's a lot of things that are failing here. Now, when you're redesigning connections, you can make a lot of different decisions to get a certain connection check to pass. So, for instance, it tells me right here what is the bolt shear, the bolt bearing, all of that. It tells me I don't have enough bolts on this beam, or I don't have a big enough bolt on this beam, right? So right now I have 3 bolts, and I would guess they're 3/4. Let's take a look. Yes, they're 3/4" bolts. So if I want to go in and make that change, that's probably going to get a lot of these things to pass. So let's go ahead and go in there and make that change. We're going to change it from a 3-bolt connection to a 4-bolt connection. So I'm going to go back into my 2D view. I'm going to click on that bolt. Again, like I talked about before, you could do it in your 2D or your 3D view, whatever you want. I'm going to go ahead and change this to be a 4-bolt connection, and then I'm going to rerun just this connection. And it's still failing. So let's take a look at the reports. Now you'll notice I got most of it to pass, right? I got the bolt shears not passing, but so I probably still need to increase. It looks like I have 70 kips of load on this, and I only have 51 kips, so I probably still need to increase the number of bolts or the size of the bolt, either one. I also have some geometry restrictions that are failing. So if I go over here and I look and I expand it, all of these checks are expandable. So you can expand them individually and look at them. So for instance, I'm checking minimum bolt spacing, maximum bolt spacing, edge distance. It tells me each individual check and what's passing and failing. So my minimum edge distance is failing, right? So I need, more than 1.56. So I need to go ahead and make that change. I have that same girder weld limitation, so that 3/16 inch weld that I need to change. Now you can look at any of these individually. Or you can expand them all. So this button at the top allows you to expand them all, and if I scroll down here, you'll see that it tells me, okay, when I'm looking at beam shear yield, here's the equation. It's equation G2-1 from the AISC manual. Here are all the different parameters that I'm using in this equation. So if you ever want to, verify the calculations by doing a hand calc and verifying it against the program, which I'd highly encourage you to do, then you can go ahead, you have all the information in order to do that. It's really helpful when you're saying, hey, you know what, I really think this is, this beam shear yield, shouldn't be at 124. I think it's probably in the 80, kip range. Then you can go ahead and go in here and realize, oh, that's right, well, I had a factor that was different. Maybe I wasn't using, the right axial force, or I didn't realize I had axial force. So it's really good to be able to go in ahead and check these. It's also really good when you're submitting these to any type of code agency because, then they can actually see all the different calcs, just like if you were going to do it by hand. So let's make some additional changes. Let's change some of the geometry on this beam. So I'm actually going to go ahead. I need to increase this here. So I'm gonna say this is, let's see, is this the one I wanted to change? I apologize. Yes. So this, I'm going to go ahead and change this and make this 1.6 and see what that is, because remember it needed to be 1.56. And I'm going to go ahead and change the weld as well. So I'm going to click on here. I'm going to change that weld size and make it that 3/16 inch. And then I'm going to rerun this connection. Now if I go down here, I can still see, okay, that was great. So that made my geometry restrictions and my girder weld limitations pass. But I'm still failing for my bolt shear and my girder weld strength. So let's go ahead and look at the weld to the girder. And it looks like I may just not have enough of a weld there. So if I were to increase this, either increase the number of rows or increase the number of bolts on this. So if I go in here and increase the number of bolts, and let's see if we can fit 5 in there. And it doesn't look like we can fit 5 in there. So let's go back to 4, and we'll just change the size of this bolt, let's say to be 7/8, and then let's rerun this connection. So I'm getting closer. So I've now made, okay, now I've got some geometry restrictions that I'm failing. So maybe that bolt size change wasn't what I wanted to do. And again, you're going to want to play around with these connections. You're going to want to see what causes it to pass, what causes it to fail, and make those changes. So let's go ahead and make the changes that we know we're failing for all of the connections, and then go back and change individual ones. So I'm going to go back up here to my group connection, and I'm going to make some changes to the group. So that girder weld, I'm going to change it so they are all 3/16. I'm going to go ahead and change the number of bolts, right, and I'm going to make them all have 4 bolts. I'm going to go ahead and change that, edge distance that we talked about. So I'm going to go ahead and change that edge distance to be 1.6 that we did with all the other ones. And now I'm going to run this group again. And you can see that just by making those changes that I knew were wrong in all of those connections, right, all of a sudden now I got about half of them to pass. So now I'm going to have to go ahead and make changes to those individual connections to get those to pass. So I can see here this plate size just probably isn't big enough. Just by looking at my 2D here, I can see, whoa, that plate size probably either isn't big enough or I've created too large of it here. So if I go ahead and change this to 1.1, and all I'm doing is going in and clicking on this and then typing. I don't have to click on it and then come over here to the spreadsheet and change it. You literally just click within here, make your change and click enter. So let's rerun this connection and see. So it's still failing, so let's go back to our report here. So it looks like I'm still failing that minimum edge distance. So I did need that 1.6 value here, but I need to make some changes to the size of my plate. So you can go ahead and there, maybe this time instead of having a 3.7-inch plate. Now this is something that I have to, that I can change either in, here, or I can change within Tekla Structures. So if I wanted to change this to say, let's make, not 500, how about 5-inch plate, and I want to rerun it. Now all of a sudden I'm getting that to pass. So again, the nice thing about RISAConnection is you can make changes to the group. You can make changes to the individual connections. It's completely up to you how you want to, make changes. But it really is nice because that grouping functionality allows you to save some time by making changes to a group all at one time instead of doing them individually. So I can go through, and let's take a look at like one of our others, like our end plate connection. And I'm going to go ahead and go in here and say, look at one of the connections and see why it failed. So if I look at my reports here, I can see that this one is failing for the beam weld. And again, it was that weld size that I changed. And this one's failing for the weld as well. So let's just go ahead and go in there, and let's change that, that weld. So let's go into our weld section, and we are going to change that to be a 3/16-inch weld. And rerun, again, just that group, and boom, just that one change changed all of those. So I have 7 different connections in here. If I'd had to make those changes individually, that would have taken a lot more time, but having that group functionality really allowed me to make those changes quickly. So if I wanted to continue doing, additional changes and making all of these different connections to pass, I could do that. But just for time's sake, I'm just going to show you some of the other features in RISAConnection, and then we'll take you back into Tekla Structures and show you how easy it is to update this model. Okay, so once you're done with all of your connections and you're ready to print your report, right, it only does it's great that they're all passing in here, but we're either going to have to verify that to our engineer or to our code checking agency, whoever is, reviewing your calculations. Well, the reports within RISAConnection give you a lot of flexibility as to what you want to add into your report. So like I mentioned, we have these, these wonderful 3D views. We also have all of these nice 2D views. So like you have a front view and a side view. Sometimes you have a top view depending upon the connection type. So like if we're looking at our, flange plate moment connection here, you have a side view, a front view, a top view. Again, they're all interactive, just like we talked about before. You click on it, it goes in there. You may want to have these included in your report. Your reports down here, you may want to include all of them. You want to expand all these checks and include all of these different design code checks that are part of it. You may want to include all of the different component information. So what is the beam size, the yield stress? What are the beam properties? What is the column properties? What are the different component properties? So what about that transverse stiffener? What about the bolts? What about the welds? What are the size of the welds? What is the weld type, E70? What is it, an A325 bolt? All of these different component information. So when you go to create your report and you go to print your report, you have the option to include whatever you want in this report. So if you wanted to include everything, you could go ahead and go in here and include everything. Everything on the left-hand side is what's available, and the right-hand side is what is actually included in the connection report. So right now I have my column to beam flange plate connection, just one of them. So let's say you have, a group of, 20-plus connections. You don't necessarily want to include all 20 connections. You may just want to go ahead and say, you know what, I know that this girder to beam clip angle is my governing one, so I'm going to go ahead and add that one. So you only have to add the governing one if you want to. So you have control over what goes in this report. You also have control over what is going to be displayed for those individual connections. So do you want to include all of the 2D views? Those are those 2D views that we talked about that look like drafting views, detail views. Do you want to include that 3D isometric view? You can do that as well. Do you want to include all the connection properties? These are what we're looking at behind, the components, the beams, the columns, the girder. Do you want to show a fully expanded view of the report, meaning all of those different detailed connections? Or do you just want to show a collapsed view, meaning just does it pass or fail? That's all I need to know. You have complete control over all of this. So let's create, I've checked all of the options here, and I'm going to generate a report. I'm just going to print this a PDF so we can view it here. And what it's going to do is it's going to create a report with all of those different parameters in a PDF format. So now I can go ahead and take a look at this report, and you'll see here that it gives you all of those different parameters. So just as a general, I love this Project Explorer summary, because this just tells you if they just really want to know whether it passes or fails. Here's the 2 connections that I'm printing, and it says that they pass. So that's kind of first off kind of a comfort level thing of, yes, all the connections checks within here are going to pass. And then here it talks about this first connection, this 30687. That's the ID within Tekla Structures. This is my flange plate moment connection. So here are all the different connection properties, right? It has all the different components, the beam, the column, the stiffeners, the bolts, the welds, everything. Then it lists my 3D view, which is that isometric view we looked at. Then it lists all 3 different 2D views, so with all of the dimensions here. And then it lists all of the checks that we're running. So remember how I expanded that check, and I'm just going to open up RISAConnection behind here and look at the reports. So you can see the reports here. And you'll notice that the geometry restrictions on the beam, that's the first one here. Geometry restrictions at the flange beam, you go back to your PDF report and it shows it here. So it's going to show you every single check that it shows within the program. So the reports are really comprehensive. You know, it really gives whoever's reviewing your calculations a good idea of the different checks that you're doing and the different values that you're using for all of these different parameters. So, you know, our reports really are one of the best features of the program. So once you've gone through, you've made all of your changes to your model here. I'm just going to save my model. I've already saved my model. Then there's a little button here called Export Connection Results Back to Tekla. Now, if you have both Tekla Structures and RISAConnection on the same computer, then you could just hit this button. It's going to take it back into Tekla Structures. If you do not have this, then you're going to go. Back here. You got to love Windows 8, right? Because it tells you, do you want to run it? So you can go. Now it's going to take all that information back into Tekla Structures. Now, if you do not have, Tekla Structures on your machine, then what you're going to do is you're going to send that RISAConnection file back to your detailer who has the Tekla Structures model. They're going to save it on their machine, and then they're going to open up the model, and they're going to say, show connection results within Tekla Structures. And that's going to bring in all of my results here. So I'm going to go ahead and bring up my results. And it shows in here, this is what they would see if they didn't have, if they were just running it, bringing in your file that you've used. Now, if you have both of them on the same machine like I do, you can also still view this. But this is just kind of like a general overview or a summary of what's passing or failing within my model. So I can go ahead and go in here and take a look at any of these individual connections, right? It shows a very similar view to what you were seeing in RISAConnection. Let me just push this out here. So it shows a very similar view to what you're seeing in RISAConnection. The big difference is going to be when you click on any of these individual ones, it really just tells you whether it passes or fails. So you're not going to be able to see the details of the connection. You're not going to be able to see, what is the actual calculation. If you want to see those detailed calculation views, you do have to open up RISAConnection. But this is a really nice summary within the program to see, what is passing and what is failing. So let's go ahead. Another nice feature of this browser here is if I want to look at, say, my column flange plate moment connections, if you highlight the connection in this report, you'll notice that it highlights it within your model. So it's very easy to tell, hey, what connections am I referring to here? So if I go over here, I'm just going to move my model here a little bit so I can see behind it. So you'll see as I click on these two flange plate moment connections, they're up here at the top, and they are being highlighted in your model. Or let's say my bolted welded connection here. As I click on it here, you'll see it highlighted it within the model. So it's very easy to see, the differences between the two. So if I want to go back in and let me take a look at these options here. Let me move in real quick. If I go ahead and go in here and I double click on this, if you remember right, we changed some of the parameters within this, and it's automatically updated those within your Tekla Structures model. So let's say you send this back to your detailer, and your detailer says, hey, look, I don't want to use a weld on this. I want to go ahead and make that a bolted connection. Well, you can go ahead and double click on this. You can change that to be a bolted connection if you want. right now we're bolted welded. You could go ahead and change that and make that into a, a bolted connection if you want. And then send it back to RISA Connection. So it's completely, you could go back and forth between the two programs as many times as you want. And they're always going to be, updated. And again, like I said before, you could do that if you have it on the same machine, or if you are, using two separate computers. Let's say you have RISA Connection on one, like we talked about, and Tekla Structures on the other. The only caveat to that is that in order for the link to run with the Tekla Structures model, you do need to have both RISA Connection and Tekla Structures installed on that machine. So the detailer will need at least one license of RISA Connection in order to get this link to work. But he never has to open it up as an individual program if he doesn't want to. They can just send you the connection file and then open that, do the calculations, and send it back. So that's kind of a good overview of, how the link works. So I want to talk a little bit about, what's coming, what's coming next. So as I mentioned before, these are the current supported connections within the RISA Tekla link. Now, RISA Connection has a number of other connection types, available. We have splices, we have direct weld, we have, vertical braces, and that's what we're working on right now is implementing those into the link so that we can, give you more options within your Tekla Structures model and have them designed by RISA Connection. So these are the currently supported connections, the clip angle, end plate, shear tab, and moment plate connections. But what's coming are future connections. This is what we're working on right now. So we are working on vertical brace connections, either a vertical brace, that's coming from a beam to a column, but also a chevron brace where two braces come into, a beam or a girder as well. We are working on additional moment connections, so the option to do a directly welded connection between a beam and a column, to do a bolted moment end plate connection, an extended end plate splice connection, and then flush and extended moment end plate connections. And then for splice connections, we're talking about doing bolted and welded and doing a bolted end plate splice connection as well. So these are all things that we're working on, things that you're going to see coming within the next 6 months to a year. We'll be releasing version 2 of the link shortly, like within the next month. So if you've downloaded the link and you're already using it, or you do that, then we're automatically going to notify you and send you an email when a new version of the link is available. So this is a good opportunity for you guys to ask any questions that you have to Debbie. My contact information is here. If you have any questions, feel free to email me directly as well. And I appreciate you guys coming today. Thank you for attending.